Welcome back to the Deep Dives. Today, we're really digging into something big, a major shift, I think, in how AI research is being approached.
Yeah, we're looking at Google DeepMind's SIMA 2 agent.
Right, the scalable, instructable, multi-world agent. And it feels like it's signaling the end of an era, doesn't it? The era of the super specialized AI.
Absolutely. For years, DeepMind grabbed headlines with these specialist champions. We all remember the agents mastering old Atari games or AlphaStar.
AlphaStar and StarCraft 2, Grandmaster level.
Exactly. But those agents were built for one thing, hitting superhuman performance. They were hyper-optimized for just one single closed environment.
And that's the strategic problem, right? I mean, what's the point of an AI that can dominate StarCraft if it can't do something simple like open a door in a different game?
DeepMind themselves essentially said that. They recognized this limit. And the goal now, it's fundamentally flipped. It's not about being the best in one sandbox anymore.
It's about competence, like general competence.
Human-like competence, that's the phrase they use, across many different worlds. So they're deliberately trading that superhuman peak for broader ability.
Okay, so the new mission is building a general AI agent, one you can instruct using, normal language.
Yeah, instructable, like you'd ask a person to do something. And it needs to work across all sorts of different game environments, not just one.
So for you listening, our goal here is to unpack the tech breakthroughs that let them do this. How did SIMA go from being, well, a simple apprentice to something more like a collaborative partner?
And to understand that, we really have to start with its predecessor, SIMA 1. Understand its limits.
Okay, let's do that. SIMA 1. That was the first step, early 2024.
Right, the foundational proof of concept.
Yeah.
People called it the instructable apprentice. And its whole design was built around this no cheating idea.
No cheating. That sounds important. What did that mean practically? Like for this embodied agent, was it limited like a human player?
Totally. It had zero special access, no looking at the game's code, no internal maps, no hints about rewards, nothing.
So its inputs were?
Just two things. Pixels on the screen, what you or I would see, and the natural language instructions it was given. That's it.
And the outputs? What could it actually do?
Only the most basic keyboard and mouse commands. Generic stuff. West key, spacebar, mouse click. Low-level actions.
Wow. So the real challenge was connecting language to vision, wasn't it? If you say climb the ladder, it had to figure out what a ladder looks like in pixels and then work out the sequence of press W, maybe jump, whatever, to actually do it.
Exactly. That's grounding language in perception. And to get that initial skill set, SIMA 1 used behavioral cloning.
Behavioral cloning. That's basically learning by watching, right? Imitation.
Yeah, a form of supervised learning. DeepMind gathered just tons of data. They partnered with, I think, 9 game developers?
Studios behind games like No Man's Sky, Ballet.
Those were 2 of them, yeah. They recorded pairs of human players. One person, the setter, would give an instruction.
Like mine that rock.
Right. And the other player, the solver, would actually do it, while the system recorded everything, the screen, the instruction, the key presses.
Okay, I can already see the problem there. That sounds incredibly slow and expensive to scale up. You're limited by how much human data you can possibly collect.
That was precisely the bottleneck. It meant SIMA 1 was fundamentally reactive. It could map an input instruction to an action it had seen before.
So it learned what? About 600 basic skills? Things you could do in maybe 10 seconds.
Something like that. Turn left, open door, gather wood, simple stuff. But its potential was absolutely capped by that human training data.
It couldn't handle complex multi-step goals. Like, find wood and stone, then build a basic shelter before nightfall.
No way. That requires planning, reasoning.
Yeah.
Stuff SIMA 1 just wasn't built for. Its architecture was too simple. It needed a fundamental rethink.
Okay, so SIMA 1 hits this wall. It's capped by the human data. It's reactive. How big a jump was SIMA 2 then? Was it just tweaking SIMA 1 or something totally different?
Oh, it was a massive leap. The sources actually call it a brain transplant. And honestly, that feels about right.
A brain transplant. What does that mean?
It means the core of SIMA 2, which they announced late 2025, isn't just a better mapping system. They integrated a Gemini model right into the center of the agent.
Google's large language model as the reasoning engine.
Exactly. That's the brain. And that single change shifted the agent completely from just reacting to actually, thinking cognitively.
So moving from that simple input-output mapping to having a cognitive core like Gemini, What does that actually let SIMA 2 do? How does that make it more general?
Well, first, it fundamentally changes the interaction model. It goes from being an instructable apprentice you just command
To more of a collaborative partner.
precisely. Because Gemini understands language deeply, SIMA 2 can process really complex multi-step instructions. It gets abstract concepts. It has genuine goal understanding now.
It can actually plan sequences beyond that 10-second window.
Far beyond. And maybe just as importantly, having that language core enables explainability.
Ah, so it can tell you why it's doing something, what its plan is.
Yeah, you can ask it, what are you trying to do? And it can respond in natural language. That makes interacting with it feel completely different, much more natural.
More like working with an AI, not just using a tool.
Right. And it also makes the agent multimodal. It's not just text commands anymore.
What do you mean? Like images?
It could potentially interpret, say, a rough sketch you draw of a structure you want built, or maybe understand the intent behind an emoji you send. It can fuse different types of input.
Okay, that's a huge step up in capability.
Hmm.
But what about that data bottleneck? SIMA 1 needed humans to show it everything. Does Gemini solve that?
That's probably the most critical advance autonomous self-improvement. This is what makes the old human data bottleneck basically irrelevant for scaling further.
How does that work? It just teaches itself.
It uses a kind of hybrid learning loop. So learning it started through bootstrapping. The Gemini model itself actually generates the first set of examples and goals.
So Gemini kickstarts the process internally.
Exactly. Then, when SIMA 2 is put into a new game it's never seen before, it learns primarily through, well, trial and error, self-directed play.
And Gemini watches over it.
Gemini acts like the supervisor. It sets goals, it gives feedback, especially when the agent fails at a task. It helps the agent figure out how to do better next time without needing a human to step in and demonstrate.
Okay, no more needing teams of people playing games for data collection. That's huge.
It completely changes the scaling dynamic.
So if Gemini solves the smarts problem and lets the agent learn on its own, now the agent just needs places to learn, right? It needs experience.
You've nailed the next problem. SIMA 2 is now this incredibly capable learner, ready to absorb experience, but it was potentially limited by the number of available training grounds.
Even with 9 game partners, there's only so many commercial games out there. You need diversity, right?
Exactly. To truly generalize, it needs endless variety. And that's where the other big piece of this puzzle comes in, Genie 3.
Genie 3, a foundation world model. What is that? Is it like a super advanced game engine?
Not quite like a traditional engine like Unreal or Unity. It's different. Genie 3 is a generative AI model itself.
So it creates worlds.
Yes, it can generate an endless variety of action-controllable, playable 3D environments, basically from a text prompt or maybe an image.
Wow, like type in create a forest with a castle and it builds a playable level.
Something like that, yeah. And the key thing is that these worlds are stable and consistent. It uses what's called an autoregressive approach.
Meaning?
It generates the world frame by frame, always looking back at the previous frames to make sure things make sense. So objects persist, gravity works roughly as expected, and crucially, the agent's actions have plausible consequences within that generated world.
Okay, I see the synergy now. SIMA 2 is the autonomous learner, and Genie 3 is the infinite source of new classrooms.
That's what the sources call the AGI factory, or the infinite dojo. It creates this amazing virtuous training cycle.
Walk me through that cycle.
Okay, so first, you give Genie 3 a prompt. Maybe it's text, maybe it's even a screenshot acting as inspiration. Let's say a third-person view of an open world. There's a house with a red door near a river.
And Genie just generates that.
Yeah.
A brand new, playable 3D space.
A completely novel world that's never existed before. Then you deploy SIMA 2 into that world.
And give it a task.
Right. Like go find the house and open the red door.
And because the world is totally new, SIMA 2 has to generalize, right? It can't rely on memorizing level layouts or object properties from games it already knows.
Exactly. It's forced to use its understanding of concepts like house, door, navigation, interaction in a completely new context. It has to adapt on the fly.
So SIMA 2 with Gemini provides the learning capability,
Yeah.
and Genie 3 provides the endless, diverse curriculum. It solves both sides of the coin.
That's the idea, tackling the bottleneck of creating autonomous agents and the bottleneck of creating enough diverse environments for them to learn in.
Okay, so if the goal now is generality, how do they even measure success? It can't be the old way, like getting the high score in one specific game.
No, the metrics had to change completely. Success is now measured almost entirely by generalization. How well does the agent perform tasks in environments it has never seen during training?
The zero-shot gauntlet, they call it.
That's the one. They throw the agent into totally new games, ones it wasn't trained on at all.
And they tested this on games like Mind Dojo, which is based on Minecraft, and that survival game Aska.
Yep. And the results really highlight the difference between the old and new architectures.
How did they stack up, SIMA 1 versus SIMA 2?
It was a stark contrast. SIMA 1, the older reactive agent, really struggled in these unseen games. Its task success rate was only around 15 to 30%.
Pretty low. Couldn't adapt well.
Not really.
Yeah.
But SIMA 2, with the Gemini brain providing that reasoning and planning ability, its success rate jumped significantly. Between 45 and 75% task success in those same zero-shot tests, that's a massive quantifiable leap in its ability to take what it knows and apply it effectively in a brand new situation.
That definitely shows generalization works. But you mentioned another finding, the one that really validates this whole generalist approach.
Ah, yes, the generalist advantage benchmark. This is where things get really interesting, maybe even counterintuitive.
What did they compare?
They took an agent trained on all the different games in their portfolio, the true generalist, and they compared its performance in one specific game against another agent that had been trained only on that single game, the specialist.
Okay, wait. Let me make sure I understand. You're saying the agent trained broadly on many games actually performed better in that one specific game than the agent that only trained for that specific game.
Significantly better, yes. That's the generalist advantage.
Wow. Okay, that kind of flips traditional thinking about specialization on its head, doesn't it?
It really does. It proves that the agent isn't just memorizing tricks for each game, it's learning something deeper.
It's learning abstract concepts that transfer.
Exactly. It's taking its experience of, say, mining from game A, harvesting from game B, and gathering from game C, and building a more robust, more generalized idea of resource collection that works better everywhere, even back in game A.
That breadth of experience actually makes it better even in narrow tasks.
The diversity of training makes the learned skills more robust and adaptable. That's the key takeaway.
Which brings us back to the bigger picture. Video games aren't the final goal here, are they? They're more like a training ground.
Absolutely. They're the sandbox, the proving ground. The real ambition is general embodied AI agents that can operate effectively in the physical world.
And that sim-to-real gap, transferring skills from simulation to reality, that's notoriously hard in robotics, right?
It's arguably the hardest problem. Simulations are clean. The real world is messy, unpredictable. Vision is noisy. Physics isn't perfect. Agents trained only in perfect sims often just break when they encounter reality.
But this whole SIMA approach seems designed to tackle that head-on.
I think so, yes. By forcing the agent to learn across this huge diversity of 3D worlds generated by Genie 3, different art styles, different physics, different rules, you're preventing it from overfitting to any one specific simulation.
It has to learn principles that work everywhere.
It forces robustness. The agent has to figure out the underlying concepts of interaction, navigation, tool use that are common across all these varied environments. And that learned robustness, that ability to handle variation, is exactly what you need to bridge the sim-to-real gap.
It's building the foundation for skills needed by, say, future robot assistants.
That seems to be the long-term play, developing spatial intelligence, object manipulation, tool use in these complex virtual worlds first.
So let's place SIMA 2 in the bigger Google picture then. They've talked about this agentic era building towards a kind of universal AI assistant. How does SIMA fit?
You can sort of see the components coming together. It looks like a three-legged stool.
Okay, what are the legs?
Well, first you have the brain, the Gemini model. That's the core reasoning, planning, and understanding engine.
Makes sense.
Then you have the agent for the digital world, Project Astra. That's the real-time assistant that can see your screen, understand context, and help you with digital tasks.
Okay, brain, digital hands.
And SIMA represents the research track for the physical agent, or at least the agent interacting with 3D space. It's being trained specifically for that spatial intelligence, the physics understanding, the interaction skills. It's giving the universal assistant potential hands and feet, initially in virtual worlds, but with the clear aim of eventually translating that to the real world.
Brain, digital agent, physical agent, all potentially powered by Gemini at the core.
That seems to be the vision they're building towards.
So wrapping this up, what's the final thought we should leave our listeners with? What's the big implication here?
I think it's about blurring lines. Consider interacting with one single, powerful, Gemini-based AI agent in the future.
Okay.
Right now, we think of asking AI to do digital things. Analyze this spreadsheet, summarize this document. SIMA 2 research is what makes the next request possible.
The physical request.
Exactly. How soon until the line disappears completely between asking it, okay, analyze all that sensor data from the experiment, and immediately following up with, and now could you please tidy up the lab bench and put the tools away correctly?
Right. Moving seamlessly from digital tasks to physical interaction.
SIMA 2's progress suggests that general physical competence isn't some far-off sci-fi dream anymore. It's becoming an engineering challenge they are actively solving. The ability for AI to interact capably in 3D space, virtual or real, is getting much, much closer.